In this video, an MAV equipped with a front and bottom-facing camera and a UGV equipped with a front-facing camera are cooperatively working together in two different scenarios. In the first scenario, the UGV MAV team cooperatively try to enter a low pathway. In a raw simulation environment, the UGV first detects the pathway and alerts the MAV. The MAV then descends until the pathway is centered in its front-facing camera's field of view. The MAV then enters the pathway using a PD controller. Once in the room, the MAV alerts the UGV that the pathway is safe to enter. The UGV then enters the pathway using a PD controller. To test our methods in hardware, we used an AR Drone 2.0 quadcopter and a Pioneer P3DX ground robot. The MAV's camera can be seen in the upper left corner of the screen, and the UGV's camera can be seen on the bottom left corner of the screen. The UGV then detects the pathway and alerts the MAV. The MAV then enters the pathway using a PD controller. Once in the pathway, the MAV alerts the UGV, and the UGV enters the room, also using a PD controller. In the end, the UGV MAV team successfully entered the pathway cooperatively in hardware as well as in simulation. In the second scenario, a pathway is not detected and the MAV guides the UGV through an obstacle-filled environment using a bottom-facing camera. The UGV's camera can be seen in the upper left corner and the MAV's camera can be seen in the bottom right corner. The MAV takes off and begins to track the UGV. The MAV then creates a graph with nodes to the left and right of each obstacle. The MAV then calculates the shortest path from the UGV to the destination, which is the orange square. The MAV then sends this path to the UGV. Lastly, once all the obstacles have been avoided, the UGV will take a straight line path to the destination. To test our methods in hardware, once again we use the AR drone and the Pioneer ground robot. Due to space limitations, we could not fly the quadcopter high enough to see all of the obstacles. Therefore, we had to simulate the directional path plan that the MAV would send the UGV. The MAV begins by taking off and beginning to track the UGV. The UGV uses the simulated directional path plan along with its front-facing camera to avoid the obstacles and proceed to its destination. In the end, the UGV MAV team was able to reach its destination by using our cooperative obstacle avoidance algorithms.